Welcome back to Missmaths. This is part 2 of our inverse functions playlist. The focus of today's video is on logarithms. Exp equals log base answer. This is something that I want you to say to yourself in your mind when you need to convert between an exponential and log, and from log to exponential functions. Since logs is classified as new work, you may be wondering what's the purpose of it. So let's look at applications and examples when you would need to use logarithmic functions. The old way that we used prime bases, this is what we did in grade 10 and 11, are as follows. Four to the power of x is equal to 64. We know that between 4 and 64, they're both prime base 2. Okay, so 2 to the power of 2x is equal to 2 to the power of 6. Since the bases are the same, you can equate the exponents and then solve. So 6 divided by 2 is equal to 3. That's the old way of doing it. And this was only possible because both bases could be expressed as the same prime base. Now let's look at an example where this is not possible. This is now the new way of solving these equations using logs. 3 to the power of x is equal to 6. Notice that 3 and 6 cannot be expressed as the same prime base. So we revert to the little song, exp equal log base ans. The exponent in our example is x. So you write that. Equals, you write the word log as per our song. Then the base is the thing which is attached to the exponent. So that's 3. And then the answer is on the other side, that's 6. So punching this in onto your calculator, the answer to x is 1,63. Looking at the following example, x is equal to 3 to the power of y plus 1. When you are presented with something like this, you always need to try to make y the subject of the formula. We are going to resort to logs because the unknown is part of the exponent. So x is equal to log base ans. So the exponent value is the y plus 1. We write log. The base is under the exponent, that's 3, and the answer on the other side is x. Now, solving y, you just need to carry over the constant. That's why it becomes minus 1. And there you've written it into log structure. Here's just another example. X is equal to a half to the power of y minus 2. Notice the slight difference between the two questions. To start off, you want the term to be alone. That's why you first carry over the minus 2 into a plus 2 to isolate the exponential term. Now you apply x equal log base ans. Exponent is y, log of the base, which is half, and the answer is the x plus 2. Now let's look at an example where you need to write it in exponential structure. So this is the opposite from what we have done in the previous examples. We have log base 3, x is equal to negative 2. Again, we use the structure x equal log base ans, but now we apply it slightly differently. Exp is the thing that stands alone in the equation, as you can see, and that is, in this case, negative 2. So negative 2 is the exponent value. Then logs do not exist when we write it in exponential. The base is the thing that is right next to the log. Okay, so look next to there, we got 3. So it's 3 raised to the negative 2. The answer is the thing which comes next to the base. So in that case, it's x. Solving 3 to the negative 2, we get rid of the negative exponents. There we go. So our answer is a ninth. Thank you so much for watching. I hope you've enjoyed this and learned something from it. If you have, please do drop a like and subscribe, and we'll see you in the next one.